Alright guys, how's it going today? What I am going to attempt to do today is redo one of my old videos that ended up being not very good. So what this is going to be is cutting square threads on a lathe. A lot of guys are kind of scared of cutting square threads. Not sure why. I've always had really good luck doing it and actually learned threading with square threads. Let's get right to it here. What you're going to need is a bit, and this is, if you can see it, it's a little tip there. It's a square cutting bit, and I cut this. And how you cut this guy is you got to figure out what you're doing. So this particular thread that I'm doing, it's again for a 1917 Enfield for no other reason than I got a receiver to screw it to, and I don't have a square nut with square threads. The minor thread diameter is 1.085, major thread diameter is 1.125, shanks 800 thousandths, and there's 10 square threads per inch. So this is pretty simple to figure out how to cut one of these guys. I'll show you, I'll kind of talk through this here, and then I'll show you this bit, and I'll show you a picture in the South Bend book. This is a South Bend book here. But the main thing we got to do is we got to figure out a helix angle. And the helix angle is that this bit, say this is just your shank, when we cut this bit for a right hand thread, our cutting, this part will stick out. This will be the little tip that's cutting. This has to be at an angle. And able to figure that out, we got to do a little math. For this particular thread, we find our helix angle, it's pi times the diameter. Our diameter is the diameter of our threads, 1.125. So pi times 1.125 equals 3.518 inches. Okay. And then if you can see it here, this is the 3.518. So that's from A to C2, so that's the bottom line. So that's the length or the circumference around our thread. Now that we have that, we can figure our what is it? Our lead, I believe, which is how far a screw will travel on that thread within one revolution of that shaft. So being that this is a single thread, the lead is equal to the pitch. So it's 1 divided by how many threads per inch we're doing. In this case is 10 threads per inch. 1 divided by 10 equals 0.01. So 0.01 is the height over here at a 90-degree angle from C2 to C. C is supposed to be right here. This is supposed to be C2. So 3.518, 0.01 high. And then we draw a line from A to the top of that line, which is C. And that gives us our degrees. I hope I got the right degree here, but I came up with 2 for this particular thread. And depending on what size your thread will be, diameter, pitch, and all that good stuff, you'll come up with a different angle here. So that 2 degrees ends up being this angle right here. And that's what I cut. This bit here, this rake is at 2 degrees this way. So we got a 2-degree cut on there. And then the next thing we got to take into consideration is how wide our cutter is going to be and how deep. So that's pretty simple. We can look in our little book here, and it gives us our depth and our space. So our depth and our depth of the thread and the distance between each thread is the same with square threads. Most square threads, not this particular one, but most of them. So all that's going to be is our pitch, which we found right here, 0.01 inches, times 1/2. So 0.1 inches times 0.5 equals 0. What is it? Oh boy. It's pretty sad when I used to be in advanced math and I can't figure out simple math anymore. It's kind of sad, isn't it? We rely on our calculators too much. I know a lot of you guys are sitting there thinking, what the heck? And I actually figured this earlier, and I'm just double checking my work. So 50 thousandths of an inch is our thread width and our thread height. I hope all that kind of makes sense. I'll take a quick shot here of the South Bend book and I'll show you kind of how all that shows up in the book. Alright, here's all that good stuff in the book. Here's our 3.518. Here's our 0.1. Here's our angle, which is B right here, which is 2 degrees. And then this guy here, if you can see this shows the helix angle on this cutter. And it shows the cutter dimensions. And you got to make sure to make the back end of your cutter here just slightly narrower than the front end. And the same thing going down the sides here. The top is going to be slightly larger, like a couple thousandths. Let me take that back. The bottom here is a couple thousandths taper on each side from the top. So only your top of your bit here is cutting. I hope that kind of gave you a good idea how we make the cutter for these square threads. So now let's actually get over the lathe and cut something.